Welcome to Bridport South Western. This layout represents part of a branch line of the London and South Western Railway on the south coast of England, set in the year 1890. The layout is modelled in EM gauge, and we're about to take you through a typical day's operation. The first train movement that we shall see is the arrival of an early morning coal train servicing the motive power depot. The bell code 1-4 heard from the signal box, the lowering of the lifting bridge and the closing of the level crossing gates heralds the arrival of this train. The next train movement will be the departure of the parcels train standing in the main platform. The bell code 131 is that of the signalman offering the parcels train further up the line. Soon we'll see the starting signal pulled off and hear the sounds of the train departing. With no more train movements for a while, the lifting bridge can be raised to allow the larger boats to pass through, and the level crossing gates can be opened to let the road traffic through. The recently arrived coal train will now have to be shunted. The first thing to do will be to remove the brake van, which will be stabled out of the way in a siding. The brake van, in which the guard rode, was always marshalled at the end of a train. As the wagons of goods trains in the period that this layout represents were all loose coupled, it was essential that the brake vans were provided so that adequate stopping power was available. Very long goods trains might have more than one brake van. The next thing to do will be to empty out the contents of the coal wagons. In a small locomotive depot, this would have been done by hand, by shovelling the contents of a wagon onto a coaling stage, and from there shovelled by hand into a locomotive tender or bunker. At this location, which is a medium-sized depot, the wagons are propelled to the top of a ramp, and from there the whole wagon is tipped up and the contents dropped into a bunker. The small tank engine that brought in these few wagons is doing this job now. This layout is built to a scale of 4 mm to the foot, or 1 in 76, and uses dual track gauges, one of 18 mm and the other of 28 mm. The former is for standard gauge track and the latter for the 7-foot broad gauge track. The system is built to EM gauge standards. The layout itself represents part of a branch line of the London and South Western Railway on the south coast of England, set in the year 1890. This branch runs from the main station of the historic town of Bridport to shunting yards, which are represented here. The layout also features mixed gauge tracks, enabling the Great Western Railway's broad gauge lines to use freight transfer facilities at this station. In addition to freight services, the location is also the main motive power depot for the London and South Western Railway. All the locomotives that you see running on this layout are built from scratch, from sheet metal. A variety of different metals are used, including brass, nickel, silver and stainless steel. Most of the rolling stock is similarly scratch built, although a few of the wagons are made from kits. The track work, on which you see the trains run, is all hand-built, using the method of soldering rail onto sleepers guillotined up from printed circuit board. All of the buildings and structures seen on this layout are scratch-built from a variety of materials, including printed circuit board, cardboard and balsa wood. The signals are built up from sheet metal. Note particularly the old-fashioned raised ball signal that protects trains from moving onto the lifting bridge when it is raised. Now that the coal wagons have been emptied, they must be marshalled, ready for departure. First, the brake van must be collected, as this always has to be the last wagon on a goods train. Then the brake van must be coupled to the empty wagons. Now, of course, the locomotive is on the wrong end of its train, so it has to run round its wagons via the turntable and the platform lines. Being a tank engine, the locomotive does not necessarily need turning, but given the opportunity, drivers would always turn their engines because it can be quite uncomfortable riding banker first with coal dust blowing in your face. This driver is no exception to the rule, and turn his loco he will. In preparation for the arrival of the next train, the level crossing gates will now have to be closed and the lifting bridge lowered in favour of the railway. In reality, this lifting bridge would have been powered by a small steam engine, and a housing for this can be seen next to the bridge. In the model, everything you see but the trains themselves are worked by hand with mechanical devices. Now that all the shunting is out of the way, the approach line is clear to receive a light engine that will be arriving on shed for servicing. The engine would have brought a long-distance train in from London or the Midlands and terminated at the town's main station a few kilometres away. After uncoupling from their train, the loco crew would be looking forward to running to their depot for a well-earned rest. The bell code 2-3 indicates that the engine has been offered to the signalman at this location. Soon we will hear the distant sounds of this engine approaching. The first thing for this loco to do on arrival is to be stabled at the coal stage, where the tender will be topped up with fuel and water, the fire cleaned and the smoke box cleared of cinders. Piles of glowing ashes can be seen on the ground, giving evidence of this activity. The bell code 3-1, heard from the signal box, tells us that the signalman is being offered a passenger train and we should see its arrival shortly. Now that the passenger train has arrived, the lifting bridge can be raised and the level crossing gates opened. Although this is principally a shunting layout for use of freight trains, occasional mixed trains for workers use the platforms. While passengers are disembarking from the just arrived train, the loco that was being serviced can now be stabled in the shed after turning. Being a tender loco, turning is essential. While turning is going on, we should perhaps sympathise with the loco crew who would have to do this by hand. These were the days before the use of power-operated turntables. After balancing the loco centrally on the table, the loco crew, one at each end, would have to heave the turntable round.
Cut.
Now that passengers have alighted from their train, the horse boxes that are on the end of it will have to be dealt with. First, they will be propelled a little way up the line, being left just short of the lifting bridge. Then the loco will return the empty coaches to the platform. The loco is now trapped at the wrong end of its coaches, and in order to release itself, it must use the traverser at the platform end. This device, which is no longer than a small tank engine, is used simply as a space saver. As far as we know, traversers were only ever used in loco repair shops or at large terminal stations, and never at country locations as controlled here. The layout itself represents part of a branch line of the London and South Western Railway on the south coast of England, set in the year 1890. In addition to freight services, the location is also the main motive power depot for the London and South Western Railway. Having run round its coaches, the locomotive can now go and collect the horse boxes that were conveniently left a little way up the line. As space is very limited at this location, the special siding for horse boxes radiates from a wagon turntable. The only way to get the vehicles into or out of this siding is with the use of ropes, chains or poles. The use of chains or poles was eventually made illegal because if one of them broke, a highly dangerous situation could arise. At some locations, at the turn of the 20th century, that this layout represents, draft horses were used for shunting. All the buildings except one on this layout that you see are built substantially from balsa wood. The advantage of this material is that it is very easy to simulate a stone effect on it by burning the individual stones on with a hot soldering iron. After this, each individual stone is laboriously painted with a subtle change of colour from an adjacent stone. This is why such a realistic effect is obtained. Having disposed of the horse boxes, the locomotive must get ready to take its coaches out again later in the day. First it will take a visit to the turntable, and then after turning will return to its coaches. The coaches of this passenger train are rickety old four-wheelers with wooden seats. These coaches would originally have been designed for the so-called parliamentary trains, where, by an Act of Parliament, all railways of Britain were required to run a certain number of trains for the common people at a penny a mile. In our period of 1890, these coaches would have been relegated to country branch line work from London's suburban services. They were probably the most uncomfortable vehicles in which any passenger had the misfortune to have to ride. As modelled, these coaches are made from sheet nickel silver. The panelling and other details are painstakingly cut from sheet and soldered into position. While waiting for its departure time, the loco of the passenger train will take on water at the column, situated at the end of the platform. The next train to depart, however, will be the empty wagons of the coal train. We might have expected the lifting bridge to be raised again after the departure of this train, but it will be left down due to the imminent arrival or departure of other trains. The first of these will be another light engine coming on shed. This engine will, like all others, first make its way to the coal stage to take on fuel. The bell code 23 indicates that the engine has been offered to the signalman at this location. Soon we will hear the distant sounds of this engine approaching. The bell code 3-1 that we have just heard tells us that the passenger train that has been waiting for some time is ready to depart. Soon we will see the starting signal come off, hear the guard's whistle blow, and finally the loco whistle will signal the departure of the train. In preparation for its movement to the Great Western Railway area of the town, the broad gauge steam rail motor standing in the goods yard must be moved into a platform road to wait for the line to become clear. The next train to arrive at this station, as heard by the bell code 1-4. This train will not have its 3 run into the station because rules stated that loose coupled goods trains of more than a certain number of wagons were required to be stopped at the home signal when approaching a terminus. This was to make sure that they were properly under control. Sometimes the drivers were annoyed by this rule, and when stopped, would vent their feelings on the loco whistle.
Now that the main line is clear, the broad gauge rail motor, consisting of an engine and coach on the one chassis, can depart for the Great Western main station of the town.
We are now about to see some complicated shunting movements, but before this happens, the lifting bridge must be raised, the level crossing gates opened, and the light engine, standing at the coal stage, turned and stabled in the loco shed where it will be serviced. The servicing of a steam engine was a labour-intensive task. Soon after arrival, the fire would have to be thrown out, and then, after as little as a couple of hours, while everything was still quite hot, the most junior of staff would have to climb into the firebox to clean ash deposits off of the firebox walls and tube ends. One can only imagine how unpleasant this task would have been. Then, depending on how many miles the loco had run since its last service, it might be necessary to remove the pistons and valves for examination by a senior fitter and for replacement piston rings to be fitted. While all this would have been going on, a small army of cleaners would be polishing every part of the loco. We are, of course, talking about the turn of the 19th century when labour was so cheap that all locomotives could be kept absolutely spotless and gleaming. The highlight of the day's operation, which is the shunting of the goods train, is now commencing. First, the brake van, which is always the last vehicle on a goods train, has to be removed and placed out of the way in a siding. In these turn of the 20th century days, all goods trains were loose coupled, with the only braking power available being that on the locomotive itself and the brake van, where the guard would apply his brake in accordance with a code of whistles from the engine. The next shunting operation will be the unloading of the minerals into a barge. This was a complicated procedure where the whole wagon will be tipped up. Power to do this will be provided by a small steam engine driven by the ship's boiler. Today, electric motors will be used to power any static device, but electricity had barely been invented in the period that this layout represents. There was certainly no grid of electricity supply that we take for granted now. The idea of this shunting layout has been to pack as much interesting operation as possible into as small a space as possible. As in all model railways, compromises have been made so that the scene is compressed. And certainly more compromises have been made here than in the average layout. To counteract this lack of size, though, a great deal of operational realism has been incorporated, so that, with a bit of imagination, the viewer can get an idea of what life was like on the railways more than 100 years ago. Those people who remember the last days of steam in this country will vouch for the fact that everything was absolutely filthy. 100 years before this, though, particularly in Britain, things were totally different, and every locomotive was kept spotlessly clean. Labour was so cheap and the working hours so long that every locomotive could be assigned to one driver only. The next piece of shunting will be for the covered van that was originally in the middle of the train to be propelled into the goods shed. The rails for this shed radiate from a small wagon turntable that is too small for both the locomotive and van to sit on together, so a clever piece of shunting will be used. Leaving the two flat wagons behind under the overhead crane, the locomotive will venture onto the main line and from here, using a long pole, push the van into the shed. Although at a country branch line, as is represented here, space was rarely so limited that wagon turntables were needed, they were very common in the larger industrial areas, right up to the 1950s. The transshipment of goods from a railway wagon to a canal barge, like we saw a few moments ago, was, in fact, a very common sight in the 19th century. As the railways expanded greatly in the early years of the 20th century, just after the period represented here, the railways and canal companies found themselves in competition, and in many cases the railways simply bought up the canal companies and closed them down. Even today, anyone who tours the byways of Britain can frequently come across disused canals with notices along their banks indicating that they belong to some erstwhile railway company. Having completed its shunting, the small tank loco will return to the flat wagons under the overhead crane, ready for transshipping its loads between similar wagons of a broad gauge train that will be arriving shortly. Now that the main line is clear again, the lifting bridge can be raised and the level crossing gates opened. We now have two goods trains in the yard, one a standard 4-foot 8.5-inch gauge train and the other a broad 7-foot 1/4-inch gauge train. With wagons from both trains positioned under the travelling crane, we shall now see how skilled the operator is in transshipping the loads of one wagon to another. One might ask how stupid the railways of Britain were in not standardising on a single track gauge. Of course, we have to remember that back in the early years of the 19th century, when railways were first conceived, governments were powerless to force all the different companies into standardising. And if one powerful engineer decided to bury his head in the sand and take a different approach to everyone else, there was little that anyone could do about it. As most people know, the railways of Australia were similarly stricken with a multitude of gauges. When railways were first built in Britain, they were confined almost entirely to coal mines, where wagons were hauled by horses or men. There were a multitude of different track gauges used in these mines, but the most common was one of 4 foot 8 inches used by George Stephenson, who was the most influential of the early railway engineers. When steam-operated public railways were first conceived, this so-called Stephenson's gauge was standardised, as George or his son Robert were the engineers for most of the early lines. Later, an extra half-inch was added to give extra clearance for long wheelbase wagons or coaches. The Great Western Railway was a comparatively late comer into the railway scene, and their engineer, the redoubtable Isambard Kingdom Brunel, would have nothing to do with anything that the Stephensons recommended. And he chose a track gauge of 7 foot that was almost twice as wide as anyone else's. Later, an extra quarter of an inch was added, again to give extra clearance. So, these two completely different track gauges coexisted for about 50 years. Gradually, the Great Western Railway saw the error of their refusal to standardise, and they were forced, initially, to lay mixed gauge tracks, as portrayed on this layout, and later to abandon broad gauge altogether. With the transshipping complete, the broad gauge train has no further interest than to get back to its own company lines. So it will be made ready for departure again as soon as possible. All that the loco needs to do is to shunt its wagons so that the brake van is on the other end of the train. Haul the wagons into the station, release itself from the wagons via the traverser that connects the two platforms, take a visit to the turntable, and then back down on its wagons from the other end. It will not be necessary to service with the broad gauge loco, because this will be done in its own depot on the other side of the city. The London and South Western Railway, who are the principal owners of this site depicted here, would certainly not lower themselves into providing a Great Western Railway loco with coal. And to make sure that this was impossible, they have not laid any broad gauge track up to their coal stage. I think it would be reasonable to assume that the two companies would have an understanding that either could use the other's watering facilities though. In retrospect, we might say that although a track gauge of around 4.5 feet was fine for the confines of coal mines, forward-thinking engineers might have envisaged that something considerably larger would be desirable in years to come, when locomotives would be a lot larger. So perhaps Brunel and his Great Western Railway colleagues were on the right lines. Certainly when the Irish started building railways, well after the English, a broader gauge of 5 feet 3 inches was used. Now the Great Western Railway locomotive has completed its running round and turning. So as soon as it gets clearance, it will be off to its own lines. With the lowering of the lifting bridge, the closing of the level crossing gates, and the sound of 3 beats on the block bells, the broad gauge goods train should soon be on its way. Now that the broad gauge goods train has cleared the station, the lifting bridge can be raised, the level crossing gates opened, and the standard gauge train can make itself ready for departure, with its wagons shunted into the correct order. As all experienced shunters know, trains have to be made up starting from the deck. Therefore, the brake van, that always has to be the last vehicle on the goods train must be picked up first. As all goods trains in the 19th century, that this layout portrays were loose coupled with simple 3-link chains, and that there were only hand brakes on the wagons that could not be operated from the locomotive. Special brake bands were needed in which the guard rode. On a signal of whistles from the loco driver, the guard would screw down his brakes to help stop the train. The empty coal wagons, which are the lightest on the train, must be attached at the back, next to the brake band. But as the 2 loaded flat wagons are in the way of these empties, the loaded wagons must be collected first and placed temporarily in another siding. One of the rules of arranging the wagons of a goods train was that the heaviest ones had to be arranged furthest forward, next to the locomotive, and the lightest wagons further back. This is of no consequence in today's air brake trains, but without continuous brakes, a sudden brake application on the locomotive might cause the momentum of heavy wagons to crush lighter ones if they were in front. Now the empty coal wagons are free to be picked up, and they will be coupled next to the brake band. The shunting of the goods train was a highly skilled job that required the close cooperation of the loco driver and a man on the ground who would have to change the points and pin down the handbrakes of wagons. All this was done with hand signals by day and hand lamps by night. When moving a long rake of wagons, the driver would have to make a little snatch at each wagon because the static friction of mainly grease-lubricated axle boxes would make the wagons impossible to move otherwise. The last thing to do will be to collect the heaviest loaded wagons, which must be furthest forward in the train. When these have been picked up, the train will be complete. This layout is built to a scale of 4 millimetres to the foot, or 1 in 76, and uses dual track gauges of 18 millimetres and 28 millimetres. The former for standard gauge track and the latter for 7-foot gauge track. The system is built to EM gauge standards. The layout itself represents part of a branch line of the London and South Western Railway on the south coast of England, set in the year 1890. This branch runs from the main station of the historic town of Bridport to the shunting yards depicted here. Now that the outgoing goods train is complete, it can be pulled into a platform road ready for departure. The locomotive is on the wrong end of the train, of course, so it will run round its wagons via the traverser and the vacant platform road, take a visit to the turntable so that it can depart chimney first, and then return to its wagons to wait for the main line to be clear once again. The turning of a tank engine is not essential, as they are designed to run equally well in either direction, but given the opportunity, drivers would always turn their engines for a number of reasons. Not least of these would be that with the controls attached to the back head of the boiler, the driver would prefer to be facing these than have them behind him. The goods train that will shortly depart is what was called a pickup goods train. This was because it was required to stop at all sidings along its route where wagons were needed to be picked up or set down. On reaching a large marshalling yard, its wagons will be coupled to various long-distance goods trains. Before the pickup goods train can depart, the lifting bridge must be lowered and the level crossing gates closed. Then it must wait for the line to become clear
of the arrival of a broad gauge steam rail motor that will be arriving from the Great Western Railway area of the town. The ringing of bells heard from the signal box is that of the signalman being offered the broad gauge train. Soon we will hear the sounds of this train arriving. The bell code 1-4, just heard, tells us that the main line is now clear for the standard gauge goods train to depart. Shortly we will see the starting signal come off and hear the sounds of the train leaving.